To find the antiderivative, many times I have to fix things before I go for it. So I'm just going to take the time to carry this along. And I'm going to separate this radical. So I have root 3, and then I have root x, but I'm going to rewrite it as x to the 1/2 so that I'm ready to take the antiderivative. The antiderivative of e to the x is e to the x. Carry along the root 3, and then I would have add 1 to the exponent, right? X to the 3/2 over 3/2. So I'm just going to do times 2/3 between 0 and 4. Okay, so I plug in the 4 first. So I get e to the 4 plus 2 root 3 over 3. Then I would have 4 to the 3/2. Subtract off. Now be careful. E to the 0 is 1. So I do have something from there. This one doesn't turn out to be anything. Okay, so I would want you to know how to do this, right? So I would have e to the 4th plus 2 root 3 over 3. So this is square root of 4, which is 2 cubed, so times 8. So there it is. All right, so remember, it doesn't matter as long as these letters match. It means take the antiderivative. Antiderivative of secant squared is tangent of t between 0 and pi over 4. So that means I have tangent of pi over 4 minus tangent of 0. So that gives me 1. And you know tangent of 0 is 1. Tangent of 0 is 0. This one, be careful. I would want you to take the time to pull this 1/2 over to the side. So this 1/2 just carries along for the ride, and now I take the derivative of the antiderivative of 1 over u, and you know that's ln of u between 1 and 5. So 1/2 ln of 5, I don't need to take the absolute values along because I took the absolute value, minus 1/2 ln of 1, and you know that that's 0. So 1/2 ln of 5 is the answer. This next one, you'd have to know the antiderivative of 4 to the x. So that's 4 to the x divided by ln of 4 between 0 and 2. So you get 4 squared over ln of 4 minus 4 to the 0. That's a 1 over ln of 4. So this is 16 over ln of 4 minus 1 over ln of 4. So that gives me a 15 over ln of 4. ln of 4 just carries along like a number. This one here, it's necessary to split this up. I don't know that antiderivative, so I have to take the time to split it up to e to the t times e squared, right? Because if they're multiplied together, right, x to the a, x to the b is x to the a plus b. So that's what this is, right? Okay, so e squared just carries along like a number, and I take the antiderivative of e to the t, and I get e to the t. So carry along the e squared. And so now I'm going to suggest we pull it on the outside. So plug in the 1, so you get e to the 1. Subtract, plug in the negative 1, e to the negative 1. So this is the same thing as saying e minus 1 over e, right? And if I wanted to multiply this in, this here would give me e cubed, and then this here would give me a minus an e. All right, this here, I'm going to have to separate it around that addition in the numerator. So 1 to 9, 1 over x squared plus root x over x squared dx. Okay, so this is not ln. Remember, the only time you get an ln is if it's exactly 1 over x. So let's take the time to rewrite both of these with it as x to a power. So 1 to 9, so this would give me x to the negative 2 power. This is x to the 1/2, and that's x squared. So if I pull it up to the top, so I would have plus, and I would get 1/2 minus 2, so that's x to the negative 5/2 dx. Okay, so now we're going to take the antiderivative, or the integral, and we increase the exponents. So I'm going to add 1 and put it over that same number, and then plus, add 1, and put it over that same number. Okay, between 1 and 9. So this is looking pretty big and ugly, so let me make some room here. So make sure you leave lots of space for your problems, right? Okay, So let's rewrite this. So let me come up here. So I'm going to rewrite this as negative 1 over x minus 2/3 1 over x to the 3/2. It's easier to deal with the numbers when you don't have negative exponents. So now I'm going to plug in the 9. So I get negative 1/9 minus 2/3 1 over 9 to the 3/2. Subtract off, now I'm putting in 1, negative 1 minus 2/3. So again, I'm going to deal with this. So I have negative 1/9 minus 2/3. So this is the square root of 9, which is 3, cube it, which is 27. And then I'm just going to distribute this negative through, so plus 1 plus 2/3. So I'm just going to leave it like that. All right, one more here. So I know this is the arctangent. And I know that this is the arcsine. And now I'm going to put negative 1 to 1. Okay, we've been practicing these. Arctangent of 1 plus arcsine of 1. And then I'm going to be subtracting off arctangent of negative 1 and arcsine of negative 1. Okay, this arctangent of 1 is pi over 4. Arcsine of 1 is pi over 2. Subtract off. Make sure I'm going to keep my negatives here. So I'm subtract off, and this gives me negative pi over 4, and this gives me negative pi over 2. So these two will add together, right? So I'll have pi over 4 plus pi over 2 plus pi over 4 plus pi over 2. So this gives me a 1 pi, and this gives me a pi over 2. So I have 3 pi over 2.